Hello everyone, thanks for coming. My name's David Malcolm. I work at Red Hat on GCC, focusing on diagnostics, user experience, and static analysis. I'm going to be talking in this session about what's new in those areas, I guess, in the upcoming GCC 16 release. Talk about improvements being made to C++ diagnostics, especially template errors. The improvements to how GCC outputs diagnostics, and by diagnostics I mean errors and warnings and that kind of thing that the compiler emits. There's a -f fanalyzer, which is the static analysis pass for GCC that I added back in GCC 10, and the improvements I've made in GCC 16. There's libg diagnostics. In GCC 15, we basically refactored things so that GCC's diagnostic code can now be used as a shared library from other programs, and they're like C, C++, and Python bindings. So you can, if you've got a Python script that's analyzing code or something, some other files, you can use our diagnostic subsystem to do, underlined, quoted fragments of the code, fix-it hints, and generating patches and that lot. I'm also going to talk about, I'm going to talk about improvements in 16 with that. And finally, some experiments that aren't in Trunk yet, and some refactoring I've done internally to try and clean up the code, because it's all got quite complicated as new features have been added. So what I think probably for end users, what might be the headline feature in 16 might be the hierarchical diagnostics for C++ template errors, this thing here. And if you're familiar with errors that come out of a C++ compiler, it's a difficult problem in which we either don't tell the user enough for them to be able to figure out what's wrong with their code, or we spam them with screenfuls and screenfuls and screenfuls of text too much. And it's sort of difficult to know, well, what should we tell the user? And the answer is probably going to be wrong, because in each case, they might need different information in order to figure out what the problem is in their code. Cy Brand, they are a UX expert at Microsoft, working on, I think, on the Microsoft toolchain, came up with this proposal, Sarah for structured diagnostics, and in that they rather than having a flat list of basically of text, is instead to have a tree-like structure of nodes, and to capture. Because there is a tree-like structure in terms of the reasoning that the compiler is making about whether the code is valid or not. And the idea to actually present that to the user in a sufficiently modern UI, potentially to have little expand collapse widgets, so the user can choose what level of information to drill down to, or what is of interest to them, as they have a hunch, oh, there's a problem with this particular aspect of the code. And so we could hopefully be maybe a bit more verbose, but let the user manage what they want to see. So this, we added it in an experimental form in GCC 15, but it was hidden behind a sort of a cheat code level command line option. But for GCC 16, it's now enabled by default in Trunk with a few fixes. And so here's the example from Cy Brand's paper, and which is some C++ code involving templates and concepts, where at the bottom here in main we try to pet a lizard object, and we have overloads at the top of pet that can take dog and that can take cat, and we also have a template at line 16 where pet can take a petable thing, and petable things either has member pet or has default or is convertible to pet. Can you call animal or t.pet on the object? This is the example taken from Cy's paper, and in GCC 15 we emit by default that, and my eyes glaze over looking at it. It's slightly improved over 14 because we added there are three candidates. Candidate 1 is there, and down there is candidate 2. So in GCC 16, we now do this indented, bulleted list where we're showing the structure of the reasoning of what it's going on. There are three candidates. Candidate 1, where we're trying to convert lizard to petable, and we can't do it for this reason, and the reasons themselves can have reasons, hence the tree-like structure. And then there's a whole load of reasons why candidate 1 doesn't work, and then down here, here's why candidate 2 doesn't work. A lizard is not a dog, or a lizard can't be converted to a dog, and candidate 3, a lizard can't be converted to a cat, kind of thing. So this is much more text. I'll actually, part of the reason why it's more text is we're actually quoting the source code more often. I think, yeah, like here we see it, I think 3 or 4 items down, both refer to line 8, but they're referring to different things on line 8. And I think in the older presentation, we're just not bothering to quote the source at all in there. So I think it's coming out as 2 screenfuls, rather than 1 on this example, because we're quoting the source more often. But I don't know, I feel this is much more readable and a big improvement. And the other thing is that, so we have machine readable diagnostic output using a format called Serif, which I'll talk about more later on in the session. And the idea is maybe we can, IDEs can consume this, and that hierarchical structure is serialized into the Serif so that a viewer can do that, do a UI where you can, drill down into what you care about. And so that's in trunk. And I'm kind of thinking this might be like a headline feature of C++ users in GCC 16. I think it's it's certainly a big change. And I'm sure some people are going to complain because it's a big change, but I know. There's some things that I've been playing around with, and these aren't in trunk yet, and I don't know if Jason's in the audience. No, I haven't actually sent this to the mailing list yet because I haven't quite got the test suite to pass with it. So here's an example. I make these sorts of mistakes all the time where we've got no declaration matches foo test in const void star int, and then the candidate is foo test in void star, and I'm thinking, well, something doesn't quite match. Where's the mismatch? And so I have a patch which instead says, okay, there's one candidate, and I try to test, parameter 3 is void star, and the parameter 3 of what you should have been is const void star, which is immediately highlighting the parameter and in both the 2 sites and using color to contrast them. And internally, I'm basically adding in the idea of a comparison between 2 type signatures, and kind of, in theory, we could do like we do in the spell checking, that idea of an edit distance between, so we could do things like, did you flip 2 arguments? Is there an extra argument? And if so, maybe the arguments 4 and 5 would line up if you hadn't added an extra one here. And I haven't got that working yet. Alex, you
get to it. Maybe you'll get to it, but have you had problems where it shows this stuff for two functions that are completely unrelated, or is that pretty good at this point? This looks awesome.
Oh, but the specifically, I'm using this in. I know you know the insides of the C++ front end. So specifically, what I did. So the stuff in here is in print Z candidates or Z candidates for printing, basically for resolving. There's like a long list, I think a page long on CPP reference of what the rules are for resolving what function is actually called when you do a function call, like all the rules for that. So let's print Z candidates in the C++ front end. This is print candidates, which is a different thing, and is used in quite a few different places for different things. And I haven't yet adjusted the wording for that, because this is line 10 there at the top. That's a definition of foo : test. And then it's basically comparing it against the different declarations that there may be available. Well, there's only one. And it's doing that it's looking at all the different foo : tests that it knows about declarations for, because you have multiple overloaded ones. I wasn't quite sure whether actually on the spelling, do I want to say there is one candidate, or just say the candidate is, and maybe we can lose a line, and there's some debate there on what it exactly should look like.
I'll see if I can break it later then.
As I say, I haven't posted the patch yet because it's not done. And thank you for volunteering to pass the microphone to the next person who asks a question.
Will do.
Okay, thanks. And for example, and the classic mistake I make when is like adding const to a member function, and it will then say parameter this is of foo star, whereas parameter this of the other one is const, parameter this of the other one is const foo star, so that it kind of captures, well, I don't know, basically this is things that I screw up in C++, making it easier on myself to figure out what I've done wrong. What?
So, you often have like APIs change. You often have APIs change and you're looking at it and you've upgraded some library and you have this huge page of errors and they didn't document what they changed and why. This sort of thing is perfect for that because you can very easily see where the mismatch is and what the candidates are for whatever new API you need to port to. So yeah, it's not just about your own mistakes either. It's about porting.
And I was thinking the class of I have a like type signature class and a comparison of two type signatures class, if you see what I mean, like a comparison of type signatures class that takes in two and do that. Maybe that's something we would generalize into other useful for other front ends, like the C front end or whatever. Like you messed up this way in the C front end, but it's all of kind of early days. But this is. As I say, I've got sort of experimental patches for that, but they don't yet. I haven't got the test suite clean on them yet. So that was some specifics for the C++ front end. Now I want to talk about changes to how we output diagnostics. And traditionally, we outputted text to standard error, and sometimes with control codes for colorization. And way back in the day, people might try and use regexes to try and carve up that output, and if they needed would prefer it in a machine-readable format. And you can kind of do that for the file colon line column colon and so on. But we've added all this extra stuff in the output, like quoting the user's source code, underlining parts of it, showing fix-it hints. Just simple things like showing which warning option, command line option controls the warning at the end of the message line. And so please don't use regexes to carve up GCC's output. Please use a machine readable format. You have your hand up.
Yeah, I just realized, we're doing that for some post-processing of the logs. Now, what we'd like to do is we'd like to keep the standard build log, so with the standard error.
Sorry.
We'd like to keep the diagnostics in standard out and standard error. Can you output to a text or to a file as well now?
You can now do both as of
Okay.
GCC 15.
Okay,
I'm just mentioning So Sarif is a JSON-based. It is a standard. There are many programs out there, producers and consumers, and there's even like I think there's a Sarif tool, multi-tool that is designed for. Doing things like linking and querying and so on. So GCC has been able to output its diagnostics in Sarif form since GCC 13, and gradually it's exactly what is output has been getting richer and richer and richer. It's a big standard that supports a lot of expressibility. In 15, I added a Sarif replay tool, which is a consumer of Sarif files, and basically plays them back as if GCC were emitting them in text form. And yeah, that's the wiki page for GCC's Serif support. And yeah, and answering your question, yeah, in 15, I added this diagnostics add output, and there's also set output, which clears the list. So there's a scheme and key value pairs, so text and so by default in GCC 15, you have your text by default, and then you can do diagnostics add output serif, and it will also send the serif to a file in it that you can then carve up as, with JSON. There was a file format, output format called JSON, rather awkwardly, which I added back in GCC 9. That was actually the first sort of non-text, as it well, it is text because it's JSON, but the first machine alternate output format, and it was basically it was GCC's what the data structures were like at the time turned into JSON form, and it has a sort of subset of useful functionality. I deprecated it in 15, and I deleted it all a few months ago in Trunk, which is great because I've been able to make a bunch of other improvements without having to carry that load around. So we have, and in terms of output formats, we can output diagnostics as text, and we can output them in machine readable form as serif. And new in 16 is HTML output. Ooh. And this is experimental -HTML. So -F diagnostics add output experimental HTML. I don't know at what point and what criteria it should be to lose that experimental weasel word prefix. But you'll see the state of it.
Just abbreviated to X.
What's that?
Just abbreviated to X.
Oh, yeah, that's a bad pun. The joke was abbreviated to X. So we had a plugin within the Deja GNU-based test suite, a GCC plugin, that basically existed as to show, can you write a new diagnostic output format as a plugin? And I kind of was, the output was very crude because all I needed. But then I found there was a few places where I actually really needed HTML output, which I'll come to on the coming slide. So I've actually decided, okay, let's promote it to, well, I guess it's not a first-class thing because it's got experimental stuck at the front of it, but a fully fledged part of the compiler. And I made a bunch of improvements. So I've been using this CSS library called Patternfly to make it look pretty. And also this HTML output functionality is available in Serif Replay. So that turns Serif Replay into a Serif to HTML converter as a nice view, which gives you a much richer view in some ways of what's in the Serif file. And also libg diagnostics. So if you have a script, like a Python script that is using that to generate diagnostics, we can now generate HTML rather than text on standard error. So here's an example of what the output looks like. We've got it's a warning, so we've got a little warning icon, whatever that triangle is. And for example, on the right-hand side, the -W format is a hyperlink to the documentation of that option in GCC's docs. There's some subtleties here. It says format %I expects argument of type int, but argument 2 has type. And you'll notice that the %I and int are both purple, and the const jar star is green. And that coloring is a bit difficult to see actually in the quoted source, but the part of the source that is intish is colored that way, and the part of the source that's const jar starish is quoted green to sort of contrast the type mismatch. And there's a fix-it hint, which is printed in the kind of quoted source as the %S, kind of hiding under the %I. But a much nicer way of presenting it, given that, hey, we've got a HTML, I'm assuming a bit more vertical scrollability, is to show a generated patch of what the suggested fix is. Alex, I don't know where the microphone got up.
Very quickly, though, that polarized.
Patches welcome. As the, yeah. Shall we move on, and then you'll remember as soon as
Okay.
someone else
You go
starts.
first. Maybe we'll.
It's a bit of a tangent, but I sort of wonder, have you thought about links to CPP reference or something for things like format specifiers?
Oh yeah. Oh, that'd be good.
Because, like the simple ones, okay, fine, but I often have to look at the exact meaning of some of the more...
Yeah, we have URL support in diagnostics. We can associate a URL and say, so it's some text and say this is a link to this URL. And I guess we don't know that we can count on that in the classic terminal output. No. I mean, and also if you're sending it to standard error and it's not directly connected to a TTY, it won't capture that URL because there's basically a SGR code for saying, okay, begin URL and then end link. Alex.
It's a small thing, but I can imagine someone new being confused by it being W format equals nothing. I'm not sure if you would rather put like equals 1, greater or equal to 1, or just equals 1. But I assume this is just a small quirk of the implementation right now.
That's how we've always done it. Well, I say that's how we've done it for the last 10 years or 15 years since I think DJ added that way back a long time ago before my time.
It does confuse people.
Oh.
Yeah, if it is, like, I can see myself being confused if I'm not super familiar with it. Yeah, so maybe it doesn't matter, but maybe it could have equals n, maybe even, I don't know.
I think there's another warning, I can't remember the name of it, where it confuses people more.
Interesting.
I'll look at it.
Yeah. I think it's something where it was really obvious that it was a huge improvement to just tell the user what the command line option controlling the warning was. And then we thought, oh, that's great, and moved on and never really thought about it again. So, yeah, and potentially you could, I suppose, have some sort of hover text over the thing. I don't know quite what the UI should be like. I mean, here's the thing, it's, at what point, this is static HTML, or statically, it is basically an HTML file that GCC is emitting into the file system, and to what extent do you want to, and here's a bunch of JavaScript that then turns it into an IDE.
I think you've got 3 choices for options, like for format. Either you should print it, the value of the option. I think you've got. Sorry. Is it? I think you've got 3 non-confusing choices here, none of which are currently being done. Either you just say we're format with no equals, or you say we're format equals the number that was actually passed by the user, or you say we're format equals the lowest value, the highest value, which still elicits that error, but not just an equals, because it's not even valid on the command line.
Yeah, or even, here's a 4th option, which I think is what actually happened in this case, which is to say, this is the option normally that we explicitly controlled by this is the warning explicitly controlled by -w format, blah, 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 but it was enabled because you selected -w all kind of thing. And there's that whole, and that's hard to implement because the logic for what warnings are enabled by this.
And the equals with nothing after it, I imagine it's supposed to mean this option takes a value, but because there's no value listed, it's very confusing. Oh, right. Well, it was easiest to implement.
Is there not a variable that just decides?
Oh, hold on. One at a time. Alex, you.
Is there not just a variable that holds the current value of W format that -all sets it to? I think that's how it works.
There is, yeah.
So we could just print that then, right?
There are things we could do.
Okay, fair enough. Okay,
maybe let's move on. This is it's kind of interesting. What I never noticed this. Is the sort of, you look at this long enough and you don't see it anymore, I suppose. Is the okay? Here's the HTML version. It's the top of the HTML version of that. What it doesn't have is expand and collapse, which would be very doable in HTML. If there are any, I was going to say web front-end developers, because we have to make that distinction here in the compiler, who know HTML and JavaScript and stuff. Please.
For the collapsing, you can actually look at the online docs page on GCC.
Yeah.
And it uses it for the older versions.
I don't know if I should say this while I'm being recorded, but I don't know that GCC's website is necessarily the model to use when deciding on. Sorry, Jakob.
It's easy, and it's one line.
Okay, fair enough. Yeah, there is an HTML element, I believe, that is explicitly expand collapse, but a lot of people do it sort of roll their own with JavaScript. And
Details is the tag you're thinking of.
details is the tag I'm thinking of. You say thank you. Yeah, and of course, without expand collapse, well, here's the zoomed in the top of it, and here's like the whole lot. But as you can see, it's a different icon and a slightly different background color because it's an error, not a warning, and so on and so forth. But okay, so the static analyzer, as well as being and in fact any GCC warning can have a predicted execution path associated with it. And so as an example, I've got this example. What this is building towards is, the reason I'm building all this is because I've been trying to debug the static analyzer, and I needed better tooling so I could visualize what's going on. So here's a silly example where we're building a singly linked list. We're basically appending 3 nodes onto a single list where the first is a global variable and we've got next pointers, and then let's just arbitrarily free one of those and then do something that would basically does a use after free at some point in the chain. And there's the implementation. It's trivial singly linked list. And so with the text UI, it would print this ASCII art interprocedural control flow. What? Okay, great. So with the HTML output, well, a few things. Right at the top, yes, it's a warning. It's got a hyperlink to the CWE that's related on the CWE pages, and again a hyperlink to the relevant command line option in GCC that controls this, and it shows where the use after free is predicted to happen, and execution path to 26 events. And here's my visualization, interprocedural visualization of an HTML form. And what I've tried to do is to visually represent the stack of call frames as a 3D stack. So you see at the bottom, there's that frame there which says test in the top right-hand corner. That is the stack frame for test. And we have some events going on there. Then we have a call into append value. And you'll see the frame for append value is sort of literally pushed on top of the frame for test with like drop shadows. And as we go down, you'll see, and eventually it returns from append value back into test. And so the interprocedural control flow is being visualized with SVG arrows. But within the functions themselves, it's ASCII art arrows, and it's like, well, there's only so much hours in the day, and I don't know. I can persuade my manager that this is a, must-have. But I like this visualization, and and what it was building towards is basically to help me debug the analyzer, but hopefully it's of use to end users as well.
This is the first use case I've ever seen HTML rendering in a terminal like that. I want that in my terminal now.
Oh, okay, right. Moving on. So yeah, this building towards this is sort of scratching my own itch, as the saying goes. So I've added a new, as I say, diagnostics add output, and you get the scheme, experimental HTML, and there are key value pairs. I've added this new show state diagrams equals yes. And if you turn that on, so basically I took some inspiration. If people know DDD, the data display debugger, and so the idea is now at each point on an execution path in a GCC diagnostic, you can capture at each point in the path, you can capture a directed graph that represents the state of memory. And so here we have a stack. Within the stack, there's a frame for append value. Where are we? It's on top of the frame for test. We have N, the pointer to node star, is pointed to, well, right now it's pointed to an unchecked 16-byte allocation because no code is checked that it's null. And then at line 17, as we go down to there, it sort of changes color because it's now a checked allocation of a 16-byte buffer. And so, and as we go on, as we return back to test, you'll see within the globals space, the first pointer points into this buffer in the heap, and you can see the fields, and it sort of knows that it should sort of print it as a struct node because that's how that pointer is referring to it. So let's visualize inside the analyzer. It tracks it all as bit offsets and symbolic values mapped to bit offsets, but hence why I wanted a better visualization for it. It'd be quite nice to say, this is a field of a struct, and to visualize that like mval, that. But it's much easier, rather than saying, yes, at bytes 8 through 15 are the integer value 42. So the mval fields 42. And then as you go through, like after you've appended 3 nodes, you've got here is the linked list visualized. And then when we call 3, I mean this is a completely made up example, but the idea is I'm constantly having to debug cases where the analyzer is thinks the code is doing something, and I'm trying to figure out, is the analyzer right, or is the code buggy, or is the analyzer buggy? And so after the free, you see that you've got the pointer is labeled as a pointer to freed memory, and then we can complain that the use after free. So the way this works internally is that part of Sarif's vocabulary is it has a whole set of part of the specification lets you specify capturing directed graphs in the JSON. And so we can serialize that. And so GCC, as of GCC 16, now any diagnostic and any event within a diagnostic path can have graphs associated with, directed graphs associated with it. And exactly what the meanings of the nodes are and the meanings of the edges are. And also nodes can be nested. So back in this diagram, there's a node globals, and within it is the node for first that has the edge to that allocation that has a parent node heap. You see it? So there's a tree structure of nodes with edges between them at potentially different levels. It's sort of the way the representation works within Sarif. And so that is now exposed to GCC diagnostics, and GCC diagnostics can have directed graphs. Which, I'm basically restating what I said before. This is a silly example in the test suite where I have a GCC plugin that issues a placeholder error and just sends a stupid graph through just to verify that things work. And so the idea is that the graph can be captured in Sarif form and looked at later by some sort of viewer. And in the generated HTML, it generates an SVG and sticks it in place. And so there's a few other, so in terms of what I have in terms of directed graph support, I have the memory snapshot thing, for my analyzer debugging, which is very much my use case for making my life easier. There are other ideas for how this could be useful. One idea I did was, this is a very ugly screenshot, but this is a dump of GCC's optimization passes. Because as well as at the diagnostic level and the event level, you can actually do it at the top level of the whole of the translation unit and associate graphs there, or the whole of the tool. So this is I'm generating a graph from passes.def of like the structure there. And it's really, really ugly, but this is just a prototype. And going back to this one, I have code to that's mostly finished to capture control flow graphs at a particular point in the compilation. And I'm basically playing around with exactly how that ties into the -f dump tree all or whatever. And so an example here is this is the HTML output, and I basically had -f, I think I did -f dump tree all, and it captures, so the Sarif would contain a serialized copy of the control flow graph, and the GIMPL statements or RTL instructions within it. And this is the HTML rendering of that. Basically takes the Sarif graph representation, has a policy for here's how I make GCC CFGs look nice in GraphViz, and then and it's basically taken from our existing GraphViz. It makes an SVG and embeds it into the HTML. So this way we can capture the state of the optimizer at any given point in the optimization, basically record, so that we can sort of look and then come back and see, well, what was the state of things. I'm not sure if this is useful, but I've been kind of dabbling with the idea of capturing optimization records and remarks in Sarif, because there is nice IDE integration for doing things like, if you look at a loop in the source code, it would be nice to have the IDE say, I didn't vectorize this loop because, and you can click and find out more information on what the vectorizer was thinking. But this is all just ideas for future. Other things that ideas, these aren't yet in chunk, is capturing the call graph, the program, or the inheritance hierarchy of the C++ inheritance hierarchy, or indeed, here's all the hash includes and then what those include, and so on and so forth, which we could capture quite easily through this mechanism. So that's sort of that was sort of the improvements to GCC's how we output diagnostics. Some specifics on improvements to the static analyzer. State graph visualization for me is a big thing, because I'm debugging this has been increasingly difficult. The big thing I'm adding is, well, whether I'm working on it, C++ support in the static analyzer. Do not use the static analyzer on C++ code. At least don't use it on GCC 15 or earlier. You will get a wall of text spam. Nothing is worth looking at, because mostly because it doesn't understand exception handling and chooses a whole bunch of paths through the code that aren't possible. So you will get meaningless results. The good news is that I have fixed the worst of that. There's an implementation of exception handling in Trunk for the static analyzer that works, apart from it does on a catch exception type. It does an exact match right now on the exception type rather than a is-a sort of inheritancy match. But it's a lot better than it was. I don't know if I'm going to finish that for 16. I'm going to try to. The other one is the named return value optimization. It didn't understand before and would always say, oh, it's a leak. And no, it's not. It's just, there was a part of GCC's IR that I didn't understand. That's now done. We've got a new warning, -w analyzer throw of unexpected type, which sort of dropped out of the exception handling implementation, though it's a dubious value. And I've got a uninitialized member in constructor warning that is mostly done. Here's an example of, here's with the text ASCII art output. If you have a malloc and then you throw a value and it says, yes, you detects the leak of the malloc pointer because as you exit the thing. And here's an interprocedural example where you malloc, you call inner, call do something, and do something could throw an exception, at which point you're leaking that allocation in the frame above. Although frankly, if you're using C++, you probably should be using std unique pointer or some kind of smart pointer. Yeah, there's this is the new warning I mentioned, a throw of unexpected type, where you have the test is marked as throwing IO error, but you throw a mem error from it instead, and it's like an exception of unexpected type. But this is kind of, as I say, this dropped out of the implementation, and it was kind of very easy to implement. But I don't think anyone uses dynamic.
Because C++ 98 feature which
Nobody uses it. As I say, it's just in the top, deprecated. Yeah. Yeah. So but it was it was kind of I understood it.
actually not just deprecated, but it's removed from the...
Yeah. Oh yeah. This I think was. I had to use a command line flag to get it to compile because so yeah. But as I say, this was kind of as I was getting my head around how exceptions are represented internally, and it was kind of that's really it was sort of a 10-liner. So I don't know. Okay, so the bad news is it's still useless. The problem is, so I fixed most of the false positives in the wall of noise. Now what happens if you try and run it on C++ code is it spins and spins and spins and finds no problems, having consumed an awful lot of CPU. And looking at it, like I have a trivial example where I have a hash include memory, and let's make a stood shared pointer using the default constructor, which is implicitly a null, therefore a null pointer, then try and dereference it. And the analyzer basically spins, spending its entire analysis budget trying to grok the very, very complicated this function in the C stat++ standard library calls this other function, which calls this, which calls that. And eventually it says, okay, I've used too many, for termination, it hits the sort of make sure we terminate threshold and stops. And so basically it's useless still. And part of the reason for that is that C++ is much more expressive. Like 5 lines of C gets you this complicated a control flow graph at the Gimple level. 5 lines of C++, it's like 2 orders of magnitude worse. And because it's doing so much more, like cleaning up objects, making sure destructors are called, and so on and so forth, which is good because it's doing all that error handling that the user would forget to do.
Don't use errors, right? Warnings, sorry.
Mm-hmm.
Yeah, thank you. Those use warning messages are very valuable because they tell me that this is C++ code, and C++ code is is a big warning, right?
Yeah. Okay. Yeah. Sega, I know you don't like C++. Okay. Right.
Is analyzer before early inline or after?
Yes, it's after.
Okay.
Yeah.
Yeah. If it would be before, then maybe you could just had a special code for most used C++ methods and just
indeed. So this is kind of coming on this slide. I so basically realized last week that the way I implemented the basic representation of control flow in the analyzer is terrible and really, really ugly and awkward. And I have a much, much cleaner representation, and I'm working on a patch to do that. If I really want to get into 16, because it'd be a huge simplification. And once that's in place, all kinds of higher level optimizations become achievable, like the sort of thing you were talking about. And so what I have in my patch is I sort of generate my own IR with, it's a particular, like a control flow graph, but with interprocedural aspects. And I now have my own little optimizer on it, which, because what's typically generated is lots and lots of no-ops. And it's like, let's just get rid of all that. And it sort of halves the complexity in terms of and in terms of the current implementation, it would be, every step it would be doing these. And if I'm stepping through it in the debugger, it's, more work to do. And so it's kind of nice to have, okay, I can optimize for simplicity of analysis. But it's on my laptop. It's okay. Improvements to Serif output. How are we doing for time? It's we're 3/4 of an hour into the slot. So improved in GCC 16. Serif supports. I don't know if I said it's the static analysis results interchange format. By the way, although it's changing in Serif 3 to the system analysis results interchange format to generalize it beyond static analysis to basic, because it's got a nice rich vocabulary for describing locations in source code, locations in binaries, bug report references. Is this a regression against a baseline kind of thing? There's all kinds of things it's got which are really useful. Logical locations. So if in namespace foo, there's namespace bar, and then there's my class, and it has a get color member function, then Serif has the concept, well, these are expressed as nested logical locations. And in 50, previously, I was sort of just capturing those without that structure. And now in 16, Serif has a way of capturing, well, here is that tree of logical locations, and the individual diagnostics can reference nodes in that tree. So a consumer can do things like show me all warnings about namespace foo or within namespace foo, and that sort of becomes trivial for the consumer. Fix-it hints now have descriptions, or some do. I kind of messed up the internal API for how we do fix-it hints. So it's the idea here is an IDE. You want to be able to pop up a apply fix-it hint. But what do you write there? Like you could say fix misspelled field color with color. Sorry, the British versus the US spelling. And right now, I kind of do but there isn't a good way. I didn't want to completely change our internal API. So right now, basically for the 90% case, I see, is this a simple addition, a simple deletion, or a simple replacement? And I do replace A with B, for example, for those cases. And that makes it in the Serif. I added a serialization parameter, which has one value that is valid, which is JSON. But the point being, I was experimenting at the time with JSON 5, which can do, where we can be a bit more compact in how we represent the data in a way that's a bit more human readable and doesn't use quite so many columns. And also there's a file format called CBOR, which is the compact binary object representation. And I was experimenting with, for my integration tests for the static analyzer, generate hundreds of thousands of Serif files, and it becomes a pain to work with. So could I reduce disk space or CPU overhead of processing them? And the answer was it didn't really help. But I didn't want to merge this support for this binary file format into Trunk because it felt like this is a security vulnerability report waiting to happen. But if people are interested in it is less bytes on the wire and so on. libg diagnostics. I mean, if that's 10 minutes to the. So this is the shared library. So sort of GCC's diagnostic subsystem available as a shared library, which we added in GCC 15. And what's new here, we've got the improvements, basically some of the improvements I've mentioned before, in that you can now, through this C API and C++ and Python bindings, you've got the nesting logical locations. We've got, actually, you can now express logical locations. I was talking about namespaces versus classes. You can now talk about XML elements, attributes, JSON objects, JSON arrays. And so if you want to complain about a problem in a JSON data file, you can express like a JSON path. Again, you can do HTML output from this. You can make directed graphs. And then the new thing actually is that your message buffers. I tried to port LD, the linker in GNU LD, in GNU binutils, to use libg diagnostics for its output. And it basically ran into that internally it's doing lots of fprintfs. And so basically this is the how to make it easy to port fprintf based code to this API. Nick.
We've been interested in doing this sort of thing in libctxt duplicator, which has layers of nested errors that can be triggered from one deep problem. And the moment I just have to either just print them all out as a stream or throw most of them away. That seems much nicer.
Okay, it sounds like we should talk. Yeah, okay, excellent. We've got like 8 minutes left till the next session. I've been playing around with IDE integration, and basically at every cauldron for the last, I don't know how long, I ask, are there any IDE developers or Emacs hackers in the room? And I never get a response. The maintainer of GNOME Builder turned up on IRC a couple of weeks ago, and we've been working on this on IRC, on an RPC thing where the idea is you set an environment variable in the build environment, or sorry, the IDE invokes, here it's invoking Ninja, and the idea is the IDE sets serif socket equals and then a path to a Unix domain socket, and then anything that knows about this, and in particular a patched version of GCC, or it could be if we add the support to libg diagnostics to the assembler and the linker and so on, sends an RPC notification every time it emits a diagnostic to the listener. And so you've got the text output at the bottom, but you also see at the top, there's this list view with 2 items where it's capturing from the serif, and it's got the whole machine readable, you know, all this rich data about the diagnostics. So this is just a mock-up that the GNOME Builder maintainer put together based on my hacked up GCC. So hopefully we can have, you know, I thrash out some IDE support. And the other experiment was capturing suppressed diagnostics, which is that serif has an option where if you've got a hash pragma disable such and such a warning, rather than throwing it away altogether, you can say, actually capture that, but mark it as suppressed by the pragma at this location. And in fact, I've got a patch, and I posted the patch, which, as well as supporting that in the serif output, adds an optional rationale that if you do a hash pragma ignore, the user can then say in the code ignored because basically a string giving the reason, and that's also captured in the serif output. And the problem is this really complicates the control inside the diagnostic subsystem. So I have not merged it yet because the patch isn't. Yeah, there are lots of nasty special cases, and I haven't quite fixed all of them. I don't know if that's going to make 16. Internal, I'm running out of time here. The diagnostic subsystem has gotten quite complicated. We call warning at. It's implicitly using global DC, the diagnostic context, which can have multiple sinks, and it's got many fields in it now. And in fact, there's also libg diagnostics using it, and the code's gotten complicated. So debugging this, I've added a dump member function to most of the classes to make my life easier from when I'm using GDB. There's also this new GCC diagnostics log that if you set in the environment, it will spew a bunch of stuff to standard error, or you can make it equal a file name, send it there. So if you have here's an error and the note, if you set the environment variable, you still get the error and the note, but embedded within it is this sort of nested view of we had a warning at, blah, 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 and that was rejected because that one isn't enabled, and then we have a perm error opt, and that was accepted, and you'll see that it's being reported by the text sync. It's also reporting to a serif sync and an HTML sync, which you don't know about from here, but it's also writing out other stuff. And potentially it could be sending stuff to that socket thing for the IDE. And for example, this is debugging inside the pretty printing code, like in a particular state during formatted printing. And a useful thing to do, actually, just generally, is in GDB call global DC, the global diagnostic context, dump. And it prints this hierarchical dump of everything that the diagnostic subsystem knows about, like things like cached source code, so on and so forth. Running out of time, and so I've done a big cleanup where we had a whole bunch of randomly named files and randomly named classes, and I've moved them most of them to this new GCC/diagnostics/subdirectory and into a namespace diagnostics and gave them sensible names. It's not as clean as I would like, but further cleanups would be much more invasive, so I don't want to do them yet. And so there were like 64 files in that subdirectory with meaningful names, but they're there and part of the diagnostic subsystem as opposed to GCC's usage of the diagnostic subsystem. So there's a separation there. And I don't think I have time for my rant about, if you look at GitHub, GCC subdirectory rate limits because there are too many files in the GCC subdirectory, it's over 1,000. But maybe I'll save that for Bob. And I think we have a few minutes for questions. So that's rather provocative, and I probably should have skipped those slides. But maybe I'll just leave that one up there we have, I think, 3 minutes until I get kicked out by the next speaker. Any questions or feedback, flames? Discussion? Well, we kind of had some along the way. How about this? Oh! Thank you.